Welcome to the educational research section of www.happynumbers.org. Today's video is dealing with measures of central tendency. In a data set, we're looking to shortcut ways to describing a large data set. In one way that we look at is the data will tend to center around certain numbers or around a certain number. And so that's called the measure of central tendency. And so we're looking for how can we determine these measures of central tendency. Of course, another way of looking at data is how it disperses, what the range of the data is, and how it deviates from the mean. But that's a different video. Here we're looking at how data tends to collect around the middle point. And again, these examples are all taken from the Learning Initiative website by Carnegie Mellon. It's a wonderful, wonderful website, free. Would encourage you to use it. All right, let's take a look. The first measure of central tendency, which I'm sure you're familiar with, is called the mean, or the average of a set of observations. And to compute the mean, we sum all of the observations, we add up all the observations, and we divide by the number of observations. So the mean, in its computation, includes every piece of data in the data set. So let's look at an example. We have the ages of our Best Actress Oscar winners, and this is a data set we've worked with. There are 32 pieces of data in this data set. I've just scrolled down, you only see part of it. So we'd have to add up all of these numbers, all 32, and then that would be the sum of all the scores, and then we would divide by the number of scores, and that would give us the mean. So let's have the computer compute the mean for us here. Well, when we added all the scores up, we got 1,243, and there were 32 pieces of data, so we divided 1,243 by 32, and we got our mean score, which is 38.8. So, pretty simple concept. We're going to give you a shot at it. We'll give you two very short data sets. Here's one with 6 pieces of data and one with 5 pieces of data. Why don't you put the video on pause, compute the means, and then turn the video back on, and we'll see how you did. Well, good. Well, let's see what the mean of this first one is. You should have gotten 9 for the mean. And the mean of the second one, 16. I hope I've computed those correctly, or I've programmed the computer to compute it correctly. If I don't, please email me and let me know. Okay, let's move on. Another measure of central tendency is the median. The median. Now, the median is different than the mean. The median is the midpoint of a set of scores. It's the middle score. Half of the scores fall below the median, and half of the scores fall above the median. And in fact, it can turn out in many distributions that the median, the actual number, is not even part of the data set. But it's that point in the data set where half of the numbers fall below, half of the numbers fall above. All right, now how do we determine, or how do we locate the median? Well, if the number of scores, which is usually denoted by n, if the number of scores is odd, like suppose we had a distribution with 7 scores in it, then the median would be the center score. And if it were a large distribution, this score would sit at the n, the number of scores plus 1 divided by 2. Let me give you an example here. It sounds a little complicated. It's really not, or I'll try to demystify it. Here we have a distribution of 7 scores. 1, 2, 3, 4, 5, 6, 7. Well, I mean, we can tell by visual inspection that the middle score is 8, because 3 scores fall below it, 3 scores fall above it. But if we had a very large data set, maybe 1,200 pieces of data, it would not be easy to. So we can locate then, if the number of scores is odd, we would arrange the scores from the smallest to the largest. If the number of scores are odd, we take the number of scores, 7, with the number of scores plus 1. So 7 plus 1 is 8. And if we divide 8 by 2, we get 4. So we know that the fourth score here would be the median. Because the number of scores are 7, we add 1 to 7 and divide by 2. So as an example, if the number of scores were, let's say, 49. The number of scores are 49. That's an odd number. So to find out at what place the median would be, we would go 49 plus 1 is 50. We would divide 50 by 2 and we would get 25. And so the median would be the 25th score in that data set if we lined it up from smallest to largest. So that's what that means. So in a data set, if the number of scores is odd, to find what place the median would be located at, you would take the number of scores, in this case it's 7, add 1 to it to make it 8, so it would be even, and divide by 2, and that number, that's the place where the median would be. So the median here is 8, and it is in the 4th position. Okay, now if the number is even, then the median equals the mean of the two center scores, and these scores sit at the n divided by 2 and the n divided by 2 plus 1 observations. All right, so let me show you this. Okay, here we have a data set. 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So the number of data in this is 8. So to find out where the median would be, it would be the mean of the score that is at the n divided by 2 place. So this is, we have 8 scores, so 8 divided by 2 would be 4. So 1, 2, 3, 4. So this would be the 4th. It would be the mean between this score and the n, which is 8 divided by 2 plus 1, which is 5. So this is the 5th score. So the median of this distribution that has 8 scores, or the even number, is the mean of 6 and 10. The mean of 6 and 10. Well, 6 and 10 is 16, and 16 divided by 2 is 8, so the median here would be 8. Now, the median, as I said before, it's not even a score in the data set, but that is the score which divides the distribution in half, because there will be 1, 2, 3, 4 scores below 8, and 1, 2, 3, 4 scores above 8. Let me go over this one more time. If the example is odd, the data set is odd, we take the number of scores in the data set, we add 1 to it, and we divide by 2, and that'll tell us the place where the median lies. In this case, we had 7 plus 1 is 8. 8 divided by 2 equals 4. So the median of this distribution is in the 4th score. 1, 2, 3, 4. So the median here is 8. If the distribution consists of an even number of data points, then we take the n divided by 2, which would be 8 divided by 2 is 4. So we take the 4th score, and we take the n divided by 2 plus 1. So 8 divided by 2 is 4. 4 plus 1 is 5. So the median will be the mean of these two scores. The mean of these two scores, 6 plus 10 is 16. 16 divided by 2 is 8. So the median here would be 8. Well, I hope that didn't confuse you. If you're in class with me, you certainly can bring this up if it did, or you may look at this again. However, if I've given a confusing explanation, it may still be confusing if you look at it again, but I hope I've made it clear. All right, let's move on. Here's our Best Actress Award data in a STEM plot. In a STEM plot. Okay, you will have to, if you're not familiar with STEM plots, you may want to see the video on STEM plots, which is on the website. Okay, Now we know that the n, the number of scores, is 32. Now 32 is an even number. So to get the median, we have to take the mean of the two center observations. Okay, so the first observation is located at the n divided by 2. So 32 divided by 2 is 16. So the first number is the 16th observation. So let's start here. 1, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16th. So there's our 16th score. That's our 16th score. And now the second one is located at the n divided by 2. So 32 divided by 2 is 16 plus 1 is the 17th score. So the median, here's the 16th, this is the 17th score. Well, the mean of those two, they're both 5, so the mean would be, the median then would be 5, because the mean of those two scores is 5. So we are in, the median then is the number 35. The number 35, and it is the mean between the 16th and 17th scores. And the mean between the 16th and 17th scores is 35. So that's how we've located then the median, here. All right, let's go on to a different one. Okay, here's two data sets. Data set here is 1, 2, 3, 4, 5, 6, 7 pieces of data, and 1, 2, 3, 4, 5, 6, 7 pieces of data here. So compute the mean and the median of both of these data sets. So why don't you put your video on pause and compute the means of both data sets. You may want to get a calculator and then turn it back on and we'll take a look at it. Okay, let's take a look at it here. Now, as we said before, the mean describes the center as an average value, and it uses every score in the distribution. So if we compute the mean and median here, the mean is 68.1. You didn't have to have all of these decimals, but 68.1 is the median, and the median is 68. They're very mean and median very close here, and you can see by this data set that it's pretty symmetrical. Let's compute the mean here. Now here we get a very different, we get the mean is 162, I'm sorry, and the median is still 68. So the median has stayed the same, but the mean is way larger than this one. And that's because of this one unusual data point here. These data sets are exactly the same except for the last number. This is 730. That's way, way different than the others. So the point here is the mean is very sensitive to extreme scores or outliers. Very sensitive to extreme scores or outliers. So the mean would only be an appropriate measure of central tendency if you're dealing with a distribution that is symmetrical, that does not have outliers. The median, as you can see, in both cases the median is exactly the same. It didn't matter this 730, this extreme score. So the median is resistant to extreme scores. So if you're working with distributions that have outliers in them, then the median would be a much better measure of central tendency. If the distribution is normal, symmetrical, then the mean would be the better measure. And so here's an example. This is a symmetrical distribution, almost looks like your bell curve, and the mean and median are 10. They're about the same. So the mean would be the best measure of central tendency here in this distribution because it's symmetrical. Now here's a skewed distribution, and this is skewed to the left. So the lower values, the extreme values, the outliers, pull the mean down a little bit. And in this kind of a distribution, the median is the best measure of central tendency because the distribution is skewed. Okay, quick review. The mean or average is the sum of all of the scores divided by the number of scores. It's very sensitive to outliers or extreme scores because it factors in the score's magnitudes. And the mean is an appropriate measure of center or central tendency with symmetric distributions with no outliers. The median is a middle score in a distribution not sensitive to extreme scores. If the distribution is not symmetrical, then the median should be the most appropriate score of central tendency. Okay, here you go. Here's 2 data sets for you. You can put your video on pause and compute the mean and median for each of those, and then if you would like, and then turn it back on and we'll go over it. Okay, well, let's see how we did. First of all, let's look at data set number 1, and I put it in a stem and leaf setup just to take a look at it. And let's compute the mean and median. Well, the mean and median are almost exactly the same. 21.5 for the mean and 21 for the median. And you would have to arrange these scores. For the median, you'd have to arrange these scores from the smallest to the largest, and then look to see which number divides the distribution in half. Let's take a look at this data set. Now this data set is very different. This data set is skewed. Notice we have a couple of possible outliers here. Most of the data points tend to fall up here. We would suspect that the mean in this distribution would be very different. And here our mean is 12.9 and our median is 6.5. 6.5. So the median in this data set here, the median would be a more appropriate measure of central tendency because this data set is skewed. This data set is relatively symmetrical, and so the mean would be the better measure of central tendency. Well, okay, that's measures of central tendency, the mean and the median. And thank you very much, and we'll see you next time.